Hey class, let's go over these 12 problems. I wanted to make sure that we did this problem because it was actually on a previous AP exam that I've seen. So let's first take a look at this little box here. And what does this mean? H of x equals the integral from a to x of f of t dt. Really, you have to think that all this is saying is that the derivative of h of x is going to equal f of x. And down here is our f of x. So this is the derivative, and we can say that h of x is the original function. So it's a different way to write it, but we've done problems like this before. So when we say let's find h of 1, well, we don't know exactly what it is, but what we can do is we can use our integral rules and say let's put in 1 for x, and we know that h of x is 1 to x. So when I put in 1 to 1, this whole thing becomes 0. And let's take a look at the next one, h of 0. Well, the same thing, if I put in 0 here, then that's going to be 1 to 0 because we start off here from 1 to x. So then when x is 0, it's 1 to 0. But notice that this is from a to b, and this is backwards, like saying this is from 1 to 0. Usually we're supposed to say going from left to right, but because this is going from right to left, this value is going to be negative. So it's going to be less than 0. Therefore, it's going to be negative. Okay, so if we're going to find the value of x for which is a maximum, now I'll show you the work here. Now, I decided that that x equals 4 is going to be a maximum. Let's look at that. That's because here's the derivative, and we are positive, and then we go to negative. We know at the 0 there's going to be a min or a max. But because we are positive, we're increasing, and then we're decreasing. So it's going to look something like this. We're increasing, and then here we start decreasing. So it'll be a maximum. Now, for this problem, we want to find a minimum. Now, there's no points where we have a 0 that is going from decreasing to increasing. So we need to then look at the endpoints. We know that the endpoints are going to be somewhere where it's going to be. So we either have at 0 or we have at 8. But think about this. If this is the derivative, then this positive time here is when it is increasing. Now, look how much area we have down here for when it's decreasing. Because the area here is greater from when it's decreasing, we might be increasing, but then the area here is greater. The position is moving at a greater distance because the area is bigger. Therefore, positive 8 is going to be the minimum. Okay, and if we want to find the x-coordinates of all the points of inflections, we know that's going to be 3 and 6 because here's a maximum and here's a minimum. And at maximums and minimums of the derivative, those are the points of inflection. Okay, so let's look at the next problem, which a lot of people were confused with this problem. So let's take a look at this. They say if f of x is this crazy function, and we know that one of the points is this, what's f of 5? This is actually quite interesting how this works. So let's take a look at the function here. Now take a look at this. This is where the magic happens. If I say this is the function that I'm going to be working with, I'm going to say that we have of f of x is 3 to x, and I'm going to add a 4 here. Now, watch why I did this. Because if I put in a 3 for x, watch here, if I put a 3 for x, then that's 3 to 3. We have 3 to 3. What happens when we go 3 to 3? This whole thing becomes 0. So f of 3 equals 0 plus 4. I put the plus 4 at the end. So therefore, f of 3 equals 4, just like it set it up here. So that's why this function right here is the function that we're going to use to find what f of 5 is. Because when I use this function and I put in 3 for x, then f of 3 equals 4. It's almost like I forced this to work here. So if we're going to look at this function that we've created, we have this function that will be true when f of 3 equals 4. So when I put in 5 in here, it's going to look like here. So what does f of 5 equal? Well, for this, all we have to do is plug it in our calculator. I'd use the NINT function in my calculator, and I end up getting f of 5 equals 4.112. Now this problem is quite similar, where we just want to find the function here. So here's the final answer. So let's take a look at this. We want to find an f of x. So here's my f of x. The derivative of f of x has to equal tan of x. Now let's talk about why this works for the derivative being tan of x. Because I know that the derivative of f of x here would be the derivative of this integral, which actually would be tan of x, therefore dy dx is tan of x. It's like saying f of x is the integral of tan. Therefore, the derivative of f of x is going to be tan. Now, why did I pick a 5 out here? Well, let's take a look here. Because I know if I put in f of 3 here, that if I put in 3 to 3, this becomes 0, and I have been getting f of 3 equals 5. So when you have this here, I force this 3 in here. Therefore, if I put a 3 up here, this whole thing becomes 0, and what's left over is this 5. Therefore, f of 3 equals 5. Okay, moving along. When we want to find dy dx, we're really just taking this part here, because we have y is the integral of this. So the derivative of y is going to be without the integral. The only problem here is that we have x to 5, and we need 5 to x. We need the variable to be on the top. So when you switch these two, it becomes negative. And then we're going to put in x for the t. So we end up getting dy dx equals negative, because of this negative here, 3x sine x. Just this, I'll put an x in for t. Okay? Next problem. This is a similar problem here, except it's even easier. We know we have this function. What is the derivative of this whole function? Well, the derivative of this function is going to be without the integral, but x in place of the t. So the final answer would be dy dx equals the square root of 2 plus cosine cubed of x. Next problem here. We want to find the total area. Now, when they use this word total area, that means that we're going to have no negative area. So all area is going to be positive. All right, there's no negative area. So here's our function, y equals 4 minus x. And I go ahead and graph it. And I'll just talk this out. I graphed this 4 minus x here, and I was able to say I want to find the shaded area in here plus this shaded area, region. And I used geometry, and I said, here's a triangle and here's a triangle. This triangle's area is right here. This triangle's area is right here. Then I can just say 8 plus 2 equals 10. Next problem. If we're going to evaluate this, we're just going to use the fact that from a to b of f of x, if I want to evaluate this, I take the integral of f of x and plug in b, minus the integral of f of a and plug in a. So here is the integral of 3 to the x. So because this is the derivative of this, so we can go back and forth this way. So 3 to the x ends up being here, and we have to go from 2 to negative 1. So we're going to plug in 2 to this, and we're going to subtract it by negative 1 into this. So I end up putting in negative 1 in for the x here. Oh yeah, because b is first. So we start negative 1 in here, and then I put 2 in here. I made sure I subtracted it, and in my calculator, I end up getting negative 7.889. Okay, now if I want to find dy dx here, we have an x cubed, which gets a little bit confusing. So we need to say that switch these two. So by switching these two, it becomes negative. I need the variable in the b location or on the top. Then I'm going to say we want to find dy dx, so I just take away this and put in x cubed. So when I put in x cubed, what ends up happening is that I have x cubed here, but the problem is that I need to use the chain rule. So when I use the chain rule here, I take the derivative of this 2, and that's going to be 3x squared. And there's the final answer. Okay, I have 3 more problems to do, but I'm running out of time in this video. I'll look at the next one.